What if the universe itself is hiding some of its most profound secrets, cloaked in shadows that even the brightest starlight cannot pierce? Across the infinite expanse of space, there are regions so dark, so enigmatic, that they defy human understanding, vast cosmic curtains known as dark nebulae. These mysterious clouds of interstellar dust and gas have the extraordinary ability to block out the light of stars, creating vast patches of darkness against the glittering canvas of the universe. But they are far more than just voids of light. They are celestial enigmas, concealing processes and phenomena that could rewrite what we know about the cosmos. In this video, we will uncover 20 of the most fascinating and baffling dark nebulae that challenge astronomers, spark scientific debates, and ignite the imagination. From shapes that seem carved by unseen forces to regions where star formation comes to a halt, these dark nebulae hold secrets that stretch the limits of current astronomy. Stay with us as we delve into the shadows of space, where each discovery raises more questions than answers, and where the universe's deepest mysteries await. Now turning to the Horsehead Nebula, one of the most iconic and recognizable dark nebulae in the universe. Nestled within the Orion constellation, this celestial formation has captivated astronomers and stargazers alike with its haunting silhouette that resembles the profile of a horse's head. Its striking appearance is set against the luminous backdrop of the emission nebula known as IC434, creating an awe-inspiring contrast of light and shadow. But beyond its eerie beauty lies an array of mysteries that continue to challenge our understanding of the cosmos. The Horsehead Nebula is a dense region of interstellar dust and gas, so thick that it obscures the light of the stars behind it. This dark veil is not just an obstacle to our view, it represents a hidden laboratory where the processes of star formation unfold, unseen and enigmatic. Scientists are puzzled by the unusually high concentration of dust within this nebula, which raises questions about how such dense clouds come together and evolve over time. Could it be the result of ancient stellar explosions, the remnants of long-gone stars, or something even more complex? The exact mechanisms that carved this distinctive shape are equally perplexing. Was it sculpted by powerful stellar winds, gravitational forces, or perhaps the radiation of nearby stars? Each theory uncovers more layers of cosmic intrigue. The Horsehead Nebula serves as both a challenge and a key to unlocking the secrets of star birth and the life cycle of interstellar matter. As we marvel at its shadowy form, we are reminded of the profound depth of space and the countless enigmas it holds, enigmas that continue to inspire curiosity and discovery. Moving forward, we find ourselves exploring Barnard 68, a dark nebula that might appear unassuming at first glance, yet holds some of the deepest mysteries in the cosmos. Situated in the constellation Ophiuchus, this nebula is a strikingly compact cloud of interstellar dust and gas. What makes it truly fascinating is its almost perfect spherical shape, an anomaly that raises tantalizing questions about its origin. How did such a geometrically precise structure form in the chaotic expanse of space? Was it shaped by forces we do not yet fully comprehend, or is it a fleeting snapshot of a more dynamic process in motion? This nebula's impenetrable darkness is another enigma. Unlike many other astronomical phenomena that reveal their secrets through emitted or reflected light, Barnard 68 stubbornly absorbs nearly all light that crosses its path. It is so dense that it creates a complete void in the night sky, a patch of darkness where stars seem to vanish entirely. This makes it incredibly challenging for astronomers to study what lies within. Is it a site of hidden star formation, or does it harbor relics of stars that have long since faded? To add to its mysterious nature, scientists have used techniques like observing how it blocks light from background stars to map its structure and composition. Even so, many elements of its internal makeup remain elusive. Barnard 68 is not just a curiosity, it is a reminder of how much of the universe is concealed from view, waiting for us to develop the tools and theories to unlock its secrets. Now turning to the Coalsack Nebula, we encounter one of the most prominent dark nebulae visible from Earth, particularly in the southern hemisphere. Its immense size and striking contrast against the bright backdrop of the Milky Way make it an awe-inspiring sight even to the naked eye. Known as the Black Magellanic Cloud in some traditions, this vast expanse of interstellar dust and gas has inspired countless legends and myths throughout human history. Among the most compelling are the stories from indigenous Australian cultures, where the dark patch is woven into star lore as the outline of a giant emu in the sky, a figure that stretches across the Milky Way itself. This celestial emu serves as a marker of seasonal changes, guiding communities in agricultural and hunting practices. Beyond its cultural significance, the Coalsack Nebula presents a deep mystery to modern science. Despite its grandeur and density, it seems remarkably devoid of detectable star formation activity. This is highly unusual for a dark nebula of its size, and it raises puzzling questions. Is the Coalsack merely in a dormant phase of evolution, or are we missing crucial clues about the conditions needed to spark the birth of stars? Could its composition or internal dynamics be fundamentally different from other dark nebulae we have studied? These unanswered questions continue to challenge astronomers, prompting further study into its internal structure and the forces at play within it. With the Coalsack Nebula, the universe offers yet another reminder of just how much remains unexplored, hidden within these vast cosmic shadows. Moving forward, we arrive at the Pipe Nebula, a strikingly shaped dark nebula located near the center of our galaxy. Its name comes from its uncanny resemblance to a smoking pipe, a silhouette that stands out sharply against the dense star fields of the Milky Way. This unique appearance has made it a favorite target for both amateur and professional astronomers alike, but its true mysteries lie far beyond its captivating shape. What sets the Pipe Nebula apart is its seemingly undisturbed and tranquil state. In the dynamic and often chaotic environment near the galactic center, one would expect such a structure to be marked by turbulence or signs of ongoing activity. Yet the Pipe Nebula appears remarkably calm, casting a puzzling contrast to the high-energy surroundings. Could this stillness be an illusion, masking processes hidden deep within its dense clouds of gas and dust? Some scientists speculate that it might harbor nascent stars in their earliest stages of formation, their faint light completely enshrouded by the nebula's thick, light-absorbing material. On the other hand, some theories propose that the Pipe Nebula might be a relic, a remnant of ancient cosmic events, quietly persisting long after the forces that shaped it have ceased. The true nature of this celestial enigma remains elusive as further exploration and advanced imaging techniques continue to probe its depths. The Pipe Nebula not only challenges our understanding of dark nebulae, but also serves as a stark reminder that even in the most unexpected corners of the universe, secrets and surprises abound. With the next phase of the journey in sight, we venture into the mystifying realm of Lupus 4, a dark nebula nestled within the Lupus constellation. Unlike the seemingly tranquil Pipe Nebula, Lupus 4 is teeming with potential, a cosmic nursery brimming with the promise of new stars being born. However, this dark nebula doesn't follow the usual script of stellar formation. Many of the stars within Lupus 4 appear to be caught in a peculiar state of arrested development, as though time itself has slowed their natural progression. This curious phenomenon has left astronomers scratching their heads, raising questions about what forces might be at play within its dense, concealing clouds. Could it be that the environmental conditions in Lupus 4 are uniquely hostile to star formation, or that some unseen factor is interfering with the process? Observations have hinted at the presence of protostars, the faint glimmers of stars in their earliest and most fragile stages of life. Yet these protostars remain elusive, hidden so deeply within the nebula's thick veil of light-absorbing material that they defy even the most advanced observational tools. As scientists push the boundaries of infrared imaging and other cutting-edge technologies, Lupus 4 continues to guard its secrets closely. This enigmatic nursery not only challenges our models of how stars are born, but also invites us to reconsider the delicate balance of forces, gravity, radiation, and magnetic fields that govern such processes. Lupus 4 stands as another reminder that in the cosmic theater, not all acts unfold in ways we expect, and the mysteries of the universe often deepen the closer we look. Moving forward, we find ourselves face to face with a nebula whose name alone stirs the imagination, the Boogeyman Nebula, formerly known as LDN 1622. This dark nebula, located near the familiar Orion constellation, owes its haunting nickname to its peculiar silhouette, which eerily resembles a ghostly figure looming in the vastness of space. Its shape is so striking that it naturally provokes a cascade of questions. How did such an uncanny form come to be? What forces molded this dark cloud of gas and dust into something so evocative? One prevailing theory attributes its chilling outline to the influence of nearby stars. These luminous giants radiate powerful winds and intense energy, sculpting the surrounding material like an artist chiseling stone. However, the Boogeyman Nebula seems to have resisted being completely eroded, maintaining its shadowy, menacing presence. This raises further questions about its internal structure and resilience. Is there something within its dense core, perhaps an unusually strong magnetic field or hidden gravitational interactions, that allows it to defy the relentless forces acting upon it? Adding to the mystery is its proximity to the Orion complex, a region bustling with star-forming activity. While the area is teeming with the birth of new stars, the Boogeyman Nebula remains steadfastly opaque, as though it is determined to conceal whatever secrets lie within. Even advanced infrared imaging struggles to penetrate its depths, leaving its interior largely a mystery. This enigmatic nature, combined with its haunting appearance, cements LDN 1622 place as one of the most captivating puzzles among dark nebulae. As we seek to unravel its story, the Boogeyman Nebula challenges us to consider the delicate interplay between external forces and the hidden dynamics within these cosmic shadows, reminding us that space still holds countless wonders waiting to be unveiled. Moving forward, we encounter the enigmatic Snake Nebula, formerly designated as Barnard 72, slithering through the Ophiuchus constellation like a celestial serpent. Its twisting, sinuous shape is a striking sight, captivating astronomers and stargazers alike. This dark nebula's serpentine form raises profound questions about the forces at work in shaping such an intricate structure. Could it be gravity weaving its mysterious threads, magnetic fields exerting an unseen hand, or perhaps the turbulent motion of interstellar gas and dust creating this elongated masterpiece? The lack of definitive answers makes the Snake Nebula a focal point for ongoing research. Scientists have turned to this dark ribbon of space as a natural laboratory for studying interstellar magnetic fields, which are notoriously difficult to observe directly. The Snake Nebula's structure offers clues about how these invisible forces might influence the dynamics of molecular clouds, guiding the formation of stars and planets over millions of years. Yet, despite its scientific significance, many of its secrets remain cloaked in obscurity. What drives the stark contrast between its twisting darkness and the luminous stars scattered around it? Does its shape hint at a hidden history of collisions or interactions with nearby stellar winds? The Snake Nebula leaves us pondering these mysteries, its sinuous shadow a testament to the intricate and often perplexing beauty of the cosmos. As we delve deeper into the story of dark nebulae, each new discovery reveals how much more we have yet to uncover in the vast, uncharted expanse of space. Now turning to the Dark Rift, an awe-inspiring feature that stretches across the heart of the Milky Way. we find ourselves gazing at one of the most mysterious and striking formations in our galaxy. This series of interconnected dark nebulae weaves through the galactic plane, creating the illusion of a massive chasm or split when observed from Earth. To the naked eye or through a telescope, it appears as though the very fabric of the Milky Way has been torn apart, an effect that has fascinated and perplexed observers for centuries. But what exactly gives rise to this dramatic void? The dark rift is not an actual gap in the galaxy, but rather a series of dense, overlapping clouds of interstellar dust and gas. These clouds are so opaque that they block the light of countless stars behind them, casting vast shadows that stretch across thousands of light years. Scientists have long studied these regions to unravel their complexities, but many questions remain unanswered. For instance, the sheer mass of these clouds is a puzzle in itself. Could they be concealing something beyond the dust and gas we can measure? Perhaps exotic forms of matter that defy current detection methods, or even undiscovered stellar objects lying dormant within their shroud. The dark rift also challenges our understanding of galactic dynamics. How did these immense dark formations come to inhabit such a prominent position within the Milky Way? Are their origins linked to ancient supernova, gravitational interactions, or other cosmic events now lost to time? As astronomers continue to probe the dark rift with advanced telescopes, they uncover hints of its inner workings, yet its true nature remains elusive. This colossal feature not only obscures our view of the galactic center, but stands as a reminder of how much of our universe lies hidden, waiting to be unveiled. Moving forward, our journey leads us to yet another enigmatic region of space, where the mysteries of dark nebulae continue to deepen. Moving forward, we arrive at the Serpens South region, a celestial marvel that stands out for its striking contrast between light and shadow. This area, located in the Serpens constellation, is home to a network of filamentary dark nebulae that weave through the interstellar medium like threads in an intricate tapestry. What makes this region particularly fascinating is its dual nature. On one hand, parts of the Serpens South burst with star-forming activity, glowing with the energetic light of young, emerging stars. On the other hand, neighboring areas remain eerily dark and inert, showing no signs of the same vibrant processes. This stark disparity has left scientists questioning what drives such contrasting behavior within a relatively compact region. Could it be differences in the density of the interstellar material, or perhaps variations in magnetic fields or gravitational forces influencing distinct pockets of the nebula? Adding to the mystery, recent observations have revealed clusters of protostars nestled within the luminous areas, hinting at a hidden network of interactions shaping this stellar nursery. Yet the darker, quieter regions refuse to give up their secrets, leaving astronomers puzzled over their apparent inactivity. The Serpens South region is more than just a study in contrasts. It is a reminder of how much we have yet to understand about the forces that govern star formation. As researchers continue to explore this enigmatic area with advanced instruments, they hope to uncover the unseen mechanisms driving both the brilliance and the silence of this celestial wonder. Now turning to Barnard 86, often referred to as an ink blot in the sky, this dark nebula presents a striking and enigmatic sight against the backdrop of the Milky Way. Its intense opacity is so profound that it almost entirely obscures the starlight behind it, making it appear like a void etched into the brilliance of our galaxy. What sets Barnard 86 apart is its sharply defined edges, which seem almost too precise to occur naturally. Unlike the gradual transitions often seen in other dark nebulae, its boundaries appear abrupt, as if carefully outlined by an unseen hand. This has left scientists pondering the processes that could create such a stark contrast. Is it the result of an unusually uniform density within the nebula, or might external forces like nearby stellar winds or magnetic fields be sculpting its edges? Adding to the mystery, observations suggest that Barnard 86 is not entirely inactive. It is believed to harbor hidden star-forming regions deep within its dense core, cloaked from view by its light-absorbing dust. These pockets of activity remain largely unobserved, as even infrared telescopes, which can often penetrate such veils, struggle to reveal clear insights. The paradox of its apparent stillness on the surface versus the potential dynamism within makes Barnard 86 a fascinating case study in the complexities of dark nebulae. As astronomers continue to refine their techniques and instruments, they hope to unlock the secrets of this cosmic ink blot and uncover the forces shaping its unique and puzzling form. Moving forward, we arrive at Linne's Dark Nebula 183, often simply called LDN 183, a region of space that stands out as one of the darkest and densest nebulae ever observed. This particular nebula is so dense that it absorbs almost all visible light from the stars behind it, creating a shadowy void that betrays little of what lies within. What makes LDN 183 truly remarkable is its extreme density, which defies many expectations about how molecular clouds behave. Typically, such clouds are influenced or disrupted by nearby energetic stars, whose radiation and winds can shape and scatter the surrounding material. However, LDN 183 appears to exist in an eerie state of isolation, with no such external forces readily apparent. This raises compelling questions about how it maintains its structure and what internal forces might be at play. The nebula is also a site of active research because it challenges our understanding of how stars form within such dense environments. Despite its intimidatingly opaque nature, astronomers have managed to detect early signs of star formation within LDN 183, hinting at the birth of a new stellar system deep within its core. However, these observations remain incomplete, as even advanced infrared instruments struggle to penetrate its thick layers of dust and gas. The combination of its seemingly untouched density, mysterious forces governing its stability, and evidence of hidden star formation positions LDN 183 as a celestial puzzle that continues to confound and inspire astronomers. Each discovery here brings us one step closer to understanding the processes shaping the darkest and most enigmatic regions of our universe. Now turning to the Dark Nebula cloaking the Tarantula Nebula in the Large Magellanic Cloud, we find ourselves faced with a cosmic enigma that seems to play a game of hide and seek with astronomers. The Tarantula Nebula, already known as one of the most energetic and chaotic star-forming regions in the nearby universe, is partially draped in a veil of dense, light-absorbing material. This dark companion not only obstructs direct observations of the Tarantula Nebula's most energetic zones, but also confounds researchers attempting to map the intricate processes occurring within. What truly intrigues astronomers is the way this dark nebula interacts with its surroundings. Despite existing in such a high-energy environment, this dark patch resists being torn apart by the intense radiation and stellar winds emanating from nearby massive stars. This defiance raises questions about its composition and whether hidden forces such as magnetic fields or unique chemical conditions could be reinforcing its stability. Additionally, the nebula's shadowy presence creates challenges in studying the full scale of star formation occurring in the region. By veiling parts of the Tarantula Nebula, it leaves astronomers to wonder just how many nascent stars or even stellar nurseries might be hidden from view. The interplay between the cosmic fireworks of the Tarantula Nebula and this mysterious dark cloud makes this region a fascinating paradox of light and darkness, fueling continuous efforts to unearth its concealed secrets. As our gaze shifts, the universe offers yet another riddle waiting to be unraveled. Now turning to the dark portion of the Keyhole Nebula within the Carina Nebula, we encounter yet another celestial mystery that captivates astronomers. Nestled within one of the most immense and volatile star-forming regions in the galaxy, This dense patch of darkness acts like a cosmic curtain, veiling parts of a dramatic stellar theater. The Carina Nebula itself is renowned for its intense stellar activity, fueled by some of the most massive and energetic stars ever discovered. Stars so powerful that their radiation and winds sculpt the very fabric of the surrounding interstellar material. Yet, despite the chaotic forces around it, the dark portion of the Keyhole Nebula remains surprisingly intact. This resilience challenges our understanding of how such dark nebulae withstand the onslaught of radiation that would typically erode or disperse similar clouds. Scientists speculate that its survival could be attributed to unusually strong magnetic fields, or perhaps an exceptionally dense composition that provides a kind of fortification. Furthermore, this dark patch doesn't merely survive, it exerts an influence of its own. By blocking light from the stars and gases it obscures, it creates a stark contrast that highlights the dynamic interplay between light and dark within the Carina Nebula. This obstruction, while frustrating for astronomers attempting to study the region in its entirety, also opens the door to questions about what lies hidden behind this veil. Could it be cloaking yet undiscovered protostars or even clues to the processes driving star formation in such a volatile environment? The very persistence of this dark nebula amidst such violent cosmic activity makes it a subject of intrigue and a reminder of the countless layers of complexity the universe continues to unveil. As the next challenge unfolds, we encounter the Tornado Nebula, a dark and enigmatic structure whose very name conjures images of celestial turbulence. This unusual nebula, with its twisting tendrils of darkness, has captured the curiosity of scientists for years. Its shape suggests the presence of powerful and unusual gravitational interactions, yet the specific forces at play remain a profound mystery. Unlike more uniform dark nebulae, the Tornado Nebula's stretched and distorted features defy traditional models of how interstellar clouds behave. Some researchers hypothesize that the nebula may be influenced by a nearby massive object, perhaps a dense star or even an unseen black hole, whose gravitational pull could be contorting the cloud into its peculiar form. Others suggest that magnetic fields, rather than gravity, could be shaping the dark filaments, with the interplay of charged particles in the environment adding further complexity. What makes the Tornado Nebula even more puzzling is the lack of definitive data about its origins or its role within its surrounding region. Is it a remnant of a long-dispersed molecular cloud, or is it a structure being actively formed by invisible forces? These unanswered questions make it a prime example of the mysteries that dark nebulae present, challenging not only our understanding of their dynamics, but also the broader mechanisms governing the interplay of matter and energy across the galaxy. Moving forward, we arrive at the hauntingly beautiful Cone Nebula, where its shadowy pillar stands as a defiant monument to the mysteries of the cosmos. This dark, elongated column of gas and dust pierces through the surrounding glowing region like a towering spire, creating a striking contrast that captivates both the naked eye and the mind. What makes this structure so fascinating is the way its edges are so sharply defined, seeming almost untouched by the intense stellar radiation from nearby young stars. Conventional scientific models suggest that such radiation should gradually erode these dense structures over time, smoothing their edges and dispersing the material into the surrounding space. Yet here, the shadowy pillar persists, as if resisting the relentless forces that seek to dismantle it. Some astronomers propose that the pillar's unusual resilience may be due to its internal magnetic fields, which could stabilize its shape and shield it from complete erosion. Others hypothesize that hidden pockets of particularly dense material within it might act as a protective core, allowing it to withstand the external barrage of energetic particles. The shadowy pillar is also a site of intrigue because of its potential role in star formation. Embedded within its dark recesses, there may be protostars, their faint glimmers masked by the dense veil of dust. Could it be that the pillar's structure itself is fostering the birth of new stars, even as it resists destruction? The answers remain elusive, but its imposing presence and puzzling characteristics make it a cornerstone example of how dark nebulae continue to challenge the boundaries of our cosmic knowledge. Now turning to the next enigma, we encounter the Great Rift in the Cygnus region, a colossal series of dark streaks that carve through the very heart of the Milky Way's disk. Spanning thousands of light years, this vast network of interstellar dust clouds creates the illusion of a split in our galaxy when observed from Earth, a visual phenomenon so striking that it has inspired countless myths and stories throughout human history. But beyond its captivating appearance lies a scientific puzzle that continues to elude clear explanation. By obscuring the light from innumerable star clusters and luminous stellar nurseries behind it, the Great Rift not only conceals some of the universe's most breathtaking sights, but also raises profound questions about what might be hidden within its shadow. Could these dark streaks be harboring undetected stellar populations, ancient cosmic debris, or even structures that defy our current understanding of galactic formation? One of the most intriguing aspects of the Great Rift is its sheer mass. Astronomers theorize that the dense molecular clouds making up this region could contain vast amounts of unobserved material, potentially including exotic matter or even remnants of early galactic collisions. Its role in the dynamics of the Milky Way itself also remains a matter of debate. Could the gravitational influence of such an extensive structure subtly shape the movement and evolution of our galaxy's spiral arms? Some researchers suggest that the Great Rift may act as a kind of filter, regulating the flow of interstellar material and influencing star formation rates in ways we have yet to fully grasp. As probes and telescopes continue to refine their gaze, the secrets of the Great Rift remain tantalizingly out of reach, challenging us to peer deeper into the cosmos and confront the unknown. As the next challenge unfolds, we arrive at the Ghost Nebula, a dark and haunting presence set against a backdrop of shimmering stars. Its eerie shape, with tendrils of dark gas stretching outward, has earned it its spectral name and a place among the most enigmatic dark nebulae in our galaxy. What makes the Ghost Nebula so captivating is not just its ominous appearance, but the strangely wispy edges that seem to blend seamlessly into the surrounding space. These delicate, almost translucent boundaries defy easy explanation, raising questions about the interplay of forces that shape this nebula. Some scientists speculate that these edges could be the result of a delicate balance between turbulence, which stirs chaotic motion within the nebula, and gravity, which works to pull its material inward. If true, this nebula may represent a unique case study in understanding how these two competing forces sculpt the cosmos. Adding to the mystery is how the Ghost Nebula appears to hover on the borderline between light and shadow, illuminated faintly by nearby stars while still swallowing most of the starlight that dares to cross its opaque depths. Could this interplay of light and darkness reveal hidden processes taking place inside? And what of the nebula's internal structure, so heavily cloaked that even our most advanced instruments struggle to see within? This dark cloud might conceal pre-stellar cores, regions where stars are just beginning to form, or perhaps it holds some entirely unknown phenomena that have yet to be discovered. In many ways, the Ghost Nebula symbolizes the duality of the universe itself, a place of creation and mystery where the answers remain just out of reach, inviting us to look closer and imagine the unseen. Moving forward, we journey into the depths of the Perseus molecular cloud, a sprawling complex of interconnected dark nebulae that stretches across an enormous region of space. This celestial labyrinth is not only vast in size but also dense with possibilities, as its intricate internal structure continues to baffle astronomers. Unlike many other dark nebulae, which often appear as isolated patches of shadow, the Perseus molecular cloud is a vibrant network of interstellar material, intricately woven together in ways that hint at hidden mechanisms shaping its form. What makes this region so intriguing is the stark contrast between its seemingly chaotic outward appearance and the underlying order that researchers suspect lies within. Studies of the cloud have revealed faint whisperings of motion and change, subtle shifts in density and pockets of activity that suggest the presence of unseen forces at work. Could these forces include magnetic fields threading through the cloud, or are they the result of gravitational interactions with nearby cosmic structures? Adding to the mystery are the peculiar concentrations of material scattered throughout the cloud. These dense zones are believed to be the birthplace of stars, but the processes driving their formation remain frustratingly unclear. Why do some regions within the cloud ignite into star-forming activity while others remain dormant for millions of years? Even the simplest questions, such as how the cloud maintains its integrity over such immense scales, have yet to find definitive answers. The Perseus molecular cloud challenges our understanding of how these immense reservoirs of gas and dust evolve over time and what hidden dynamics govern their behavior. As researchers delve deeper into its enigmatic core, they hope to uncover clues not only about the Perseus molecular cloud itself, but about the nature of star birth and the hidden architecture of the universe. Now turning to the blue Horsehead Nebula, we encounter one of the more enigmatic and visually arresting formations in the cosmos. This lesser-known dark nebula, named for its faint resemblance to the silhouette of a horse, resides in a region where mysteries of light and shadow converge. Unlike the more commonly discussed Horsehead Nebula, the blue Horsehead Nebula presents a striking duality. Its dark, obscuring dust clouds are contrasted by regions of reflective dust that scatter starlight into a soft, ethereal glow. This interplay between light absorption and reflection raises fascinating questions. What dictates the distribution of these contrasting elements within the nebula? Could it be subtle variations in the dust's composition, or perhaps unseen interactions with surrounding stellar radiation? The reflective nature of certain areas suggests the presence of fine, silicate-rich particles, yet the darker regions hint at denser, less penetrable concentrations of interstellar material. These differences paint a picture of a nebula that defies simple categorization, existing as both a veil of darkness and a mirror to starlight. Adding to the intrigue is the nebula's position within its local stellar environment. Does its haunting shape result from external forces like stellar winds, or could internal turbulence in the surrounding gas have sculpted its features? Furthermore, researchers are drawn to the way this nebula blurs the line between light and dark, challenging our understanding of how such transitions manifest in space. Observing the blue Horsehead Nebula provides a rare glimpse into the cosmic dance of light and material, inviting us to question the delicate balance that shapes these celestial phenomena. While many answers remain elusive, this nebula serves as a reminder of the universe's capacity to surprise us, urging further exploration into the layers of complexity hidden within its shadowy form. Moving forward to the cold core of the Taurus molecular complex, we delve into a region that embodies the quiet, concealed workings of the universe. This dark nebula, buried deep within the Taurus constellation, is a stellar nursery in the truest sense, harboring the raw materials necessary for star formation. What makes this region particularly fascinating is its extraordinary density and frigid temperatures, conditions that create a near-perfect environment for the delicate processes involved in forming new stars. Yet, much of its activity remains invisible to conventional telescopes, hidden behind thick layers of interstellar dust. This raises a compelling question. How can we uncover the secrets of such an opaque region? Astronomers rely on advanced infrared and radio technologies to peer deeper into its shadowy depths, revealing tiny flashes of activity that hint at stars in their earliest stages of life, known as protostars. These observations suggest that the Taurus molecular complex is teeming with potential, a cosmic cradle nurturing countless future stars. However, its dense, dark layers also mean that many of these processes occur entirely out of reach from even our most sophisticated observational tools. The cold core challenges our understanding of star formation by demonstrating just how much of the universe operates beyond the limits of conventional detection. Its role as a hidden stellar nursery emphasizes the universe's capacity to keep its secrets, reminding us that every dark region might hold untold wonders waiting to be discovered. As we continue to refine our technology and methods, the Taurus molecular complex stands as a beacon for what remains to be explored, urging us to push the boundaries of what we know about the cosmos. Now turning to the broader issues of visibility, let us revisit the Horsehead Nebula, one of the most iconic and enigmatic dark nebulae in the universe. Its haunting silhouette against a glowing backdrop is not just breathtaking but also a stark reminder of the limits of our observational capabilities. The dense interstellar dust within the Horsehead Nebula creates an almost impenetrable barrier, blocking visible light and leaving us with only faint clues about the processes hidden within. This opacity is not unique to the Horsehead Nebula, but is a defining characteristic of dark nebulae across the cosmos, presenting a persistent challenge to astronomers. While traditional optical telescopes struggle to see past these thick veils of dust, even more advanced infrared observatories often face limitations. Infrared wavelengths can penetrate some of the obscuring material, revealing dim glimmers of activity, yet they are far from providing a complete picture. This raises a critical question: how can we truly uncover the secrets concealed within these cosmic shadows? Scientists have begun employing innovative methods, such as using radio telescopes to detect emissions from molecules hidden deep within the dust clouds. These observations help map the structure and chemistry of dark nebulae, shedding light on their internal dynamics. Additionally, multi-wavelength approaches combining optical, infrared, and radio data are being developed to create a more detailed, layered view of these mysterious regions. For the Horsehead Nebula, such techniques have revealed pockets of star formation that would otherwise remain invisible. These methods represent only the beginning as researchers continue to refine tools and instruments capable of pushing through the cosmic darkness. The Horsehead Nebula exemplifies the challenges of studying dark nebulae, but it also inspires a relentless pursuit to overcome these obstacles, reminding us that with each technological breakthrough, we take one step closer to unraveling the universe's most elusive mysteries. Moving forward, let us revisit the Pipe Nebula, an enigmatic formation near the heart of our galaxy, whose silent depths hold clues to the grand mechanisms shaping the Milky Way. While its distinct outline, resembling a smoking pipe, has long piqued the curiosity of astronomers, the true intrigue lies in its potential connection to galactic evolution. Large-scale dark nebulae like the Pipe Nebula are not merely bystanders in the cosmos. They might play an active role in sculpting the very structure of galaxies. Observations suggest that such vast clouds of interstellar dust and gas could serve as reservoirs of raw material, feeding the processes that form new stars and planetary systems. But this is only half of the mystery. Could the Pipe Nebula and others like it also act as anchors or scaffolds, subtly influencing the shape and alignment of galactic arms over eons? Theories propose that the gravitational forces exerted by these dense dark regions may interact with the broader mass of a galaxy, contributing to the spiral patterns that define galaxies like our own. The question remains, are these nebulae passive witnesses or active participants in the cosmic dance? By delving deeper into the Pipe Nebula, researchers aim to uncover the secrets of its mass distribution and its interaction with surrounding stellar populations. Cutting-edge simulations and multi-wavelength observations are helping scientists piece together clues, enabling them to explore whether these dark veils might conceal hidden forces that govern galactic dynamics on a colossal scale. Studying the Pipe Nebula is like examining a single thread within a vast cosmic tapestry, yet the insights gained could reshape our understanding of the interconnected processes that define the universe. As the investigation continues, it becomes ever clearer that the role of dark nebulae in the grand evolutionary story of galaxies is far greater than we once imagined, compelling us to revisit everything we thought we knew about these shadowy celestial giants. Now turning to the dark portion of the Keyhole Nebula, nestled within the Carina Nebula, we encounter one of the most perplexing examples of dark nebula stability. While the surrounding region is a chaotic battlefield of intense radiation from massive stars, this dark patch seems to defy expectations, holding its ground against the relentless onslaught. Scientists have long been puzzled by the resilience of such nebulae, wondering what forces could allow these dense clouds of dust and gas to retain their structure in such hostile environments. One theory points to the role of internal magnetic fields. These magnetic fields, invisible but powerful, could act as a stabilizing framework, counteracting the pressure of external radiation and turbulent stellar winds. But their exact strength and configuration remain a mystery, as traditional observation methods struggle to penetrate the thick veil of the nebula. Another intriguing possibility is the existence of hidden forms of matter within the nebula, such as dense clumps of cold gas or even fragments of dark matter that may provide additional gravitational support. Though evidence for such exotic components is still sparse, their presence could help explain the surprising stability observed in this and other dark nebulae. The dark portion of the Keyhole Nebula serves as a reminder of how much remains hidden in plain sight, challenging astronomers to refine their models and expand their understanding of the complex interplay between gravity, magnetism, and radiation in shaping the universe. As we continue to investigate these enigmatic structures, we might uncover not only the secrets of their endurance, but also new insights into the fundamental forces that govern the cosmos. As we draw our journey through these 20 dark nebulae to a close, one thing becomes abundantly clear: these enigmatic clouds of dust and gas are more than just celestial shadows. They are gateways to profound mysteries that challenge everything we know about the universe. Each nebula, from the iconic Horsehead to the haunting Ghost Nebula, holds secrets that push the limits of our understanding, forcing us to rethink the dynamics of star formation, the role of magnetic fields, and even the possibility of unseen forces like dark matter. They remind us that the cosmos is not just a vast expanse of stars and galaxies, but a complex tapestry woven with light and shadow, each thread telling a story of creation, destruction, and the forces that bind it all together. As we continue to peer deeper into these veils of darkness, we are not only uncovering their secrets, but also daring to ask questions that may redefine our place in the universe. What else lies hidden just beyond our reach, waiting to be discovered? Let your imagination wander to the edges of the unknown and beyond. And now we want to hear from you. Which nebula captivated your curiosity the most? Share your thoughts in the comments below. If you enjoyed this voyage through the mysteries of the cosmos, make sure to like this video, subscribe to our channel, and hit the notification bell so you never miss out on the wonders of the universe. Together, let's keep exploring the endless possibilities that lie hidden in the stars.